All right, let's talk about dew point. Temperature and dew point, a very important topic, okay, for pilots. Now, what is a dew point, and why do I need to know this, right, as a pilot? If you have had the chance to maybe begin your flight training, or perhaps you're already a licensed pilot, as you get the weather for your departure or your arrival points, they will give you the temperature and the dew point. It's given every time. And the question might be, why do I need to know that? Okay, well, that's what we're going to define right here. So let's talk about the dew point. The dew point is the temperature that you would have to cool the current air mass to get visible moisture. You say, well, what in the world does that mean? Well, let me give you an example before we go on too far here. If you have ever gotten a cold drink, your favorite drink from your favorite fast food restaurant, and you've got a bunch of ice in it, and that cup is sitting on that table, and what happens? It begins to sweat, we call it, right? And there's all this kind of moisture just beating up on the straw itself. You can see that on the outside of the straw, perhaps certainly the cup itself, because it's got all that cold liquid in there. What is it doing? It's cooling. That air surrounding it is moist enough that it reaches its dew point when it touches that cold cup or that cold straw. So that demonstrates to you that you've got some humidity, for example. So if you live in the south or if you're in more humid areas, it's going to be more the case. All right, dew point. It's a temperature at which, if you cooled the air, it would make visible moisture. Okay. Now, what is a cloud? A cloud is made up of tiny little water droplets. Okay, dew, for example. And so when we cool the air down to its dew point, we create visible moisture, and that actually will create clouds. Before we move on to more of this topic about clouds, let's look at this idea of temperature and dew point and how they kind of relate. Let's say, for example, we have a cube of air here, or some kind of volume of air, all right? And let's say that the blue dots represent air molecules. When we heat air up, what tends to happen to it? It expands, right? If you heat anything up, it'll expand. If you can't get your ring off of your finger, what should you do? What you do is you put your hand under some cold water, and what happens? Those fingers are going to just shrink. They're going to contract a little bit, just enough to slide that ring off that finger. Cold contracts, heat expands. It's true about most substances. This applies to air as well. So if we heat air up, the air molecules, what it does is it excites them. All right, they start moving around faster, and literally what they do is they bounce off of each other and they spread out. So they move further apart from each other. So the air is less dense. And this is a very important topic as we step into weather and even performance. Later on, we're going to talk about performance. It's vital that you understand this relationship, especially between temperature and air density. So as my air temperature goes up, my air density goes down. All right, pop quiz for you. Here you go. Pop quiz, question number 29, and this is out of the Gleim test prep book. If you're using that, this topic of weather is all about chapter 7 in the Gleim. Question number 29: the amount of water vapor which air can hold depends on the. Here you go. We answered this question earlier. Depends on the what? A, the dew point, B, the temperature, or C, the stability of the air. When we talk about especially the stability of the air mass, we can't really tell a lot unless we see clouds. Because if we've got a cloud, then we've got a visual representation of the stability of that air. So we're going to talk about that. For example, two general types of broad categories. Let's just give it a broad stroke here. The first one would be a stratus type of cloud. And the stratus cloud is flat and kind of more feather-like. It's very thin, and it's not very defined. Its edges are kind of more loose. Okay. And the other type of cloud is a cumulus cloud, which is more vertically developed, typically. Okay. It's more knobby and more sort of looking like popcorn. And its edges can also be a little bit loose at times, but also be more defined, very defined. You may have been on the airliner seat, having your seatbelt hooked on when the captain put on the seatbelt sign, because you could see there's a bunch of these cumulus clouds around, and as you're going through them, you're getting bumped pretty good. But if you go through as an instrument pilot, specifically, I guess I should say, you're going through these type of clouds that are stratiform or stratus, this is a much more mild cloud. It's not very vertically developed. So it's showing us that there's not a lot of vertical moving air up and down drafts, or as we call it, convective currents. So the type of cloud, what it looks like, is going to give you a visual representation of what is going on in the air. A cold front is going to bring in some of the nastiest type of weather. The reason it does that, and we kind of alluded to this one earlier in the session, is because of the nature of a cold front. First of all, because it's colder air coming in to warmer air, the cold air tends to want to sink, and it wants to be bottom heavy, right? So that's going to really hug, that cold air is going to be hugging that ground, and it creates sort of a shoveling type of effect. In other words, as this colder air is pushing its way in, it's advancing on the warmer air. The warmer air is forced to go up and over the top, really, because again, warm air wants to be up top, cold air wants to be on the bottom. But as it does this, that's the lifting action. And as that air goes up and over the top, it of course cools and it condenses. And this shoveling effect or this lifting effect can be quite vertically extensive, creating some of the most menacing types of weather. Now the symbol of a cold front is the little barbs here. They're kind of like little triangles. They're blue in shape. Think of that as cold blue, ice cold blue. And that might help you. The direction that those are pointing is also significant, because that means that the front is moving in that direction. Here's just a sort of a 3D kind of a look at that warm, moist air. We can see here we got 55, 50 degrees surface temperatures, and behind the front, look at that, 25 degrees, quite cold back there. And as this cold air is pushing its way in, you got a good sense of what's going on here. It's going to shovel that warm, moist air up and over the top, and of course, as it ascends, it's going to cool, condense, and create some pretty good clouds. In this case, it looks like a CB, a cumulonimbus cloud. There's your lightning bolt right there.